Hi there, my name is Job Daniel Martin Absalarde, and today we're going to do an experiment for Science 808. The title of this experiment is Gears 2. So what we're going to do now is we're going to investigate gears.
Using what?
Using a baby bicycle. The materials we're going to need are as follows. Of course, a baby bicycle in place of a hand egg beater. Okay, so we're gonna look how many turns of the wheel happens in one turn of this pedal.
Okay, so what's the reference?
This. So
Okay.
it's at the top now. Slowly turn it.
Okay. Sige. Okay. So the wheel has turned complete one turn. The pedal almost, and there.
So it's at
Apparently
1 3/4 for one turn of the pedal.
So what does that imply?
That implies that the larger the gear in front should be larger than the gear in the back if you want to create a larger force. The bigger in front, the better. The smaller in the back, the better.
Oh, and then what do you mean better in the sense of what?
Since the larger gear is responsible for making the small gear turn multiple times in one turn of the gear. So usually you will see that in going up mountains, the mountain bikes have a larger gear in front than in the back.
So, di ba, the ratio of the one turn of the pedal is 1 3/4 turn of the wheel.
Yes.
For the wheel to turn 3.5 times, which will that will mean how many pedal turns?
Huh?
For the wheel to turn 3.5 times.
It will take 2 turns.
2 turns. So 2 turns the pedal, the wheel has already traveled how far?
How many times again?
You look at the if the gears are the same, with one turn,
the other will also turn once.
Oh, what's the length that will have traveled with one turn?
1.
Kaya nga, ano yung distance ma-move ng bike?
It will, I think, wait, will it move? It will move.
Through what distance?
Through a very small distance.
What distance?
1.
One what?
1.
How far?
At the same as, I don't know how to
analyze mo. Are you sure you do not know? What will be the distance traveled?
The length of the chain, I think? No. The length of the bike. No.
No? Are you sure?
The length of the wheel.
Length of the wheel?
The diameter. Circumference of the wheel.
So the circumference of the wheel...
The wheel or the gear? The wheel, yeah.
Circumference of the wheel. So if you know the circumference of the wheel...
That's how far your bike will go.
Now since it moves 1 3/4 turns, the wheel turn 1 3/4 and the pedal turns 1, is that good or bad?
It's good.
Why?
Because in just one turn, it's more than one turn, so that means there's more force. If you bike, there is a greater force to move. Just in one, it will not move it will move farther in one turn of the...
With a certain effort of turning it once,
it will move farther.
It will move farther than just one turn of the wheel. What if we reverse? The gear in the bike is smaller than the one at the back.
That's not effective.
That's not effective. Because imagine with one turn your bike has not moved much. Have you encountered such?
Yes.
Where?
Sometimes on mountain bikes. Or
Mountain
you can
bikes.
make, but
So that happens when the gears in the pedal is smaller than the one at the back.
yes, I
But
know.
why?
Because it takes.
When
takes
is that
more-
setting used?
I'm not sure actually. I think it's for flat. Going up. Wait,
No,
going down.
going down.
But why? Why didn't they just use normal gears?
I think that what's the granny gears?
Granny gear is the largest gear in front and the smallest gear at the back. That's for going up.
Huh?
Granny gears for going up.
For going up, large gears in front, small. Ah, okay.
Unless you want to. but
So
it will be
going
fine.
up, so that means when there's a large, by one turn of the pedal,
It moves more.
the back wheels have already moved many times. So
Yes.
that's the granny gear that's going up.
Yes. it's
Wouldn't that be difficult?
It's easier than, of course, the smaller gear in front and larger gear at the back.
But how come when we see bikers moving uphill, they are pedaling so many times but not moving much? What do you think is the setting in that case?
The smallest in front and the largest at the back?
I suppose.
That's gonna be so ineffective.
Are you sure?
I mean,
I think you should investigate that.
later? I don't know.
But what do you think? Have you not tried
But
that?
it increases the force.
There's more effort, but I don't know.
And I can't do it with my bike.
But what's your guess?
I don't know.
From my experience, it's more difficult to move the bike with the large gears in front and small at the back. Unless your legs are used to that.
I don't know. I don't know why we
I find it more difficult to pedal many times that was only moving a fraction. But I find it more effective when going up. The granny gears. No, not granny gears. I don't know what you call that.
Granny gear is always for going up.
Large in front, but small back.
I don't know. If granny gear is always the one that you call when you're going up, so that means if the small is in front, then that is the granny gear.
Oh, yun ang granny gear. That's what when you see. That's when you. That's the setting of the bike when you see bikers while moving up, they are pedaling, making a lot of pedal turns
I don't know.
going up. It's easier in the sense to turn, but of course it takes more turns nga lang. So anyway, so what have we learned from this?
That it takes more force.
Huh?
Yeah, but
No. Going back to the experiment we just did. If we differ, if in the case of the bicycle,
in the case of the bicycle,
just moving along the horizontal or
Just
flat
moving on.
surface,
Yes.
Kaya it is effective when, it's more efficient when what?
when the larger gear is in front and the smaller gear behind.
Okay.
So that's all for today. Thank you.